Hello. So today we are going to have a quiz at the end of lecture. It will be on Git from last week, but I think it'll be okay. Kind of the most important thing. So this week we will all be starting the final project. So I'm going to give a lecture, kind of giving a brief intro to what the final project is and how to get started with it. The idea with section this week is to hit the ground running, to see what you can implement, see how much of the project you can understand, see if you can delegate jobs to people on your team. Definitely finish up like homeworks 3 and 4. Homework 4 is a prerequisite in order to even start the project. I think there's still a few groups that have not yet sent their invitations to receive starter code for the final project. So please, as soon as possible, if you have not yet received your starter files, please complete homework 4 so that the instructors can give you your starter files. And it would probably be useful if all of you could probably just like right now go and pull up your starter files that you've received on GitHub, because we're going to walk through the documentation just a little bit, so just so that you can understand it a little better. Okay, cool. So let me first, this will be good. Okay. So I posted this page on Canvas. So this is an explanation of the final project. So it is the banana emulator, and you can read all about it here. Hopefully some people have already looked at this. But before we dive into it, what is an emulator? Does anyone know? Has anyone done like video game emulation before, where you've like downloaded and okay, cool. So we got some people. Yeah, so there are lots of software implementations of emulators. An example emulator would be like if I want to emulate the behavior of the Nintendo GameCube, and so someone maybe writes something in C++ where it appears like on my computer, like I can run like a video game disc as if it was like running on an actual GameCube. So okay, I want you to see if you can come up with an explanation, like a really good definition of what an emulator is with the person sitting next to you. So take a minute, come up with a good definition for what an emulator is. Yeah. A translator that goes from what a machine expects. I kind of like that. I guess, you could have an emulator that has some sort of translation in it. I like that. Can we be a little bit more abstract than that? Like, yeah. So, yes.
So I would say that an emulator uses your computer's architecture to emulate a different architecture so you can run different programs that were not designed for your architecture.
Sure. So it's the idea that you can run a program on your computer even though the program was not designed to run on your computer. Yeah, I like that. I want to even go like just a little more abstract than that. Let me remember. So what I think emulation is I guess it depends on how abstract you want to go, but like I would imagine that it is software that implements the behavior or the experience of something else. So in this case, we are we want to design an emulator for the video game console. So we want to effectively capture what the user experience would be like if someone actually owned the physical console. And so what we can do is we could probably, instead of like having HDMI output and putting that into like a nice big TV or something, maybe instead is we just draw like a window on our screen using some sort of GUI library. And maybe instead of like plugging in a cartridge and getting the experience of plugging in a cartridge, instead we emulate that by just having like the file that we drag and drop into our application. So that is the idea with an emulator. It is some bit of software that replicates the experience or the behavior of something else. How would this be different from simulation? Kind of side tangent. Anyone hear of simulation? What would the difference between like emulation and simulation be? It's kind of like, I don't know, maybe it's not as concrete of a difference, but anything? Anyone? Yeah.
Emulation would be like the process of, like it's actually running, but then you're just broadcasting an image of that onto something else or like another screen. So you could have one server run
I'm not quite following, but I think maybe you're on the right track. Anyone else? Any ideas of what a simulation is? In my opinion, I think that a simulation is it's kind of like when you emulate the implementation details. So it's less about the overall user experience, but instead simulation is when you are trying to see the inner workings of the actual implementation of the of whatever source hardware or software that you're trying to emulate. So for example, like if you wanted to do a circuit simulation, you would probably look at how the circuit was like designed. You'd look at all the wires, you'd look at all the capacitors and resistances, and you would keep like an analog voltage value of like all of your little nodes because you care about the implementation details. But with emulation, you actually don't care exactly how everything is implemented. Instead, you just want to get like the overall kind of experience of the thing that you're emulating. So that's the kind of difference between simulation and emulation. Yeah, okay, cool. So here I have pulled up the PDF that that describes the project and what it is expected of you. I'm going to quickly skim through this so that you all look at it, but make sure that you read this probably several times this quarter. It will talk about everything that is due, and then after we look at this, then we will start looking at some of the starter code that you all received. Okay, so first, I'll read the quick little explanation. So it says, your group will implement an emulator for the fictional video game console, the Banana. Your group is provided a manual explaining the architecture of the console, and you are also given several ROM files for your emulator to run. So ROM files, this is basically you can just think of it as like a game. It's an application that shouldn't necessarily work on your computer, but we're telling you like, here's the documentation, like try to get this application working anyways. That is what the ROM file is. ROM meaning read-only memory, meaning you should read it so that you can just run it and you're not trying to like edit the ROM file. Yeah, please do not edit any of the ROM files. That will be bad. Cool, okay. So, but the main goal of this course is actually, like, yes, emulation is cool, video game emulation is cool. The most important part of this course, though, is to gain practice dealing with large-scale software projects, and specifically, in this case, large-scale C++ projects. It is not trivial at all to create a large and scalable code base with maybe like a couple dozen like source files with a bunch of directories and with CMake and third-party libraries that all works with Git and GitHub and with 5+ contributors on. That's a very challenging problem, is just the organization of all that. And also thinking about how to create all of your different functions and classes and like really thinking critically. It's like, okay, like does this line of code actually benefit to the overall picture of what I'm working towards? Like if I go and add like this extra function, it's like, is this actually going to be used by anything? Is this going to create unnecessary coupling that will make the program harder to change in the future? There's just a lot of challenges that you will run into, and challenges that you will only see if you're having to create a large-scale software project from scratch. So this class, yeah, is meant to be it's meant to be practice for you dealing with large software projects. The actual C++ implementation is not actually that important. I'm not spending that much time on C++ in this class. The main reason for that is you can kind of ask ChatGPT to do most of it for you. And so it's kind of hard to teach a class that like asks you to practice your C++ implementation strategies when you can kind of just go on ChatGPT and just ask it to implement something for you and it spits out a correct answer. So that's kind of the reasoning for why I've laid out this class this way, is ChatGPT is really, really bad at dealing across multiple files and thinking in terms of like a large project. But it's really good at helping you, like if you have like 10 functions that you're trying to all implement one line, like the functions will be helpful once you have them done. That would be a great use case of ChatGPT. It's like, hey, can you just implement all of these functions for me? Yeah, cool. Yes, so that is the overall goal of this project. So the grading for this, so you are going to be in groups of 4 to 5, and the most important part is for every person in your group to contribute meaningfully. And contribute doesn't necessarily mean contribute lines of code. It could mean that, one person writes maybe a third of all of the code in the entire code base, or maybe even more than half. But maybe someone else is the expert on architecture, or is the expert on testing, or is the expert on GitHub integrations and continuous integration. It is just important that everyone in some way contributes meaningfully to the project. Maybe you have one person who's at the computer typing everything away while you have a crowd of people behind them who is throwing in ideas. It's okay that your name isn't associated with every single line of code in the project. You could still get a really good grade in the class, even if you maybe only implement just a couple functions. So it's a little bit subjective in the way that we grade, I will say, but it's important to just stay communicative with your TA and the tutors, just so that we really have a good understanding of what every person in your group is working on at any moment. In your sections, you're going to have a bunch of staff all walking around asking if you need help. Please come to each section with questions ahead of time. Ask the TAs and tutors really good questions so that you can use section time appropriately. And if you ask really good questions in section, then that is also a sign that you are at least thinking about and engaging with the project, and that would also lead to a higher grade for you, being engaged in section. Cool, okay. Section is required starting, I guess, last week, I think, or this week. Section is required. You must be at every section. If you are not at every section, it's not a big deal. Please do not message me. I am not really aware exactly what's happening in section. If anything, you should message your TA, but the most important person to message if you're not going to be there. Can you imagine who the most important people to message are if you're not going to be there? Who's the most important person to reach out to if you're not going to be in section? Your group mates, yeah, right. That's the most important thing. If we come over and Steve is not in class today, and we say, hey, where's Steve? And your group mates all say, oh, he has a doctor's appointment, but it's okay, he's been working hard this week. That is effectively the same as marking on time, present this week. So it's not a big deal if you have to miss occasionally, but just be communicative with your section mates. And please, I guess, try not to, I don't know, you're all adults and most of you are seniors about to graduate. You don't need to let us know every time that, I don't know, that you have to miss. If you, the overall participation is more important than every single attendance. Yeah, okay, cool, good. So there are 2 check-ins before the official final project is due. The first check-in is in just a couple weeks from now, I believe, February 7th. So the idea with this first check-in is that you should have all of the CPU and the memory implementations done. It's going to be very challenging getting over that first hump of the learning curve. It's going to be really challenging. I recommend starting as soon as possible. Really engage with all the starter code as soon as possible. Ask really good questions. You're welcome to collaborate across groups to try to understand the assignment better. Question. Oh, okay, I will fix that. This is correct. I remember, yes, so the February 7th, this is the due date, for the first check-in. Second check-in is then just a couple weeks after that, which is the 28th. This is for the GPU and input modules. Just read through the starter code and it will make more sense. Cool, here's what is required for the check-ins. Please go and read this. Okay, collaboration. So very important, probably this week, think about what you want to delegate to each person in your team. Maybe you'll have one person that is going to come up with the directory structure. Maybe some person is still just working on getting their GitHub set up. But make sure at the end of your section this week, at least every person should at least have something that they're going to work on that week. And maybe that should be your goal every single week is you show up and it's okay, what did you achieve last week and what are you going to achieve this upcoming week? And okay, Cool. GitHub, you must use GitHub. You should all receive your starter code through GitHub. If you have not yet received your starter code, please finish homework 4 so that you can do so. You are graded significantly on your code quality. So if you have if you're not using Clang format, or if your variable names don't make any sense, we will not check you off. Even if your code works perfectly, and even if it's the fastest submission in the class, the highest frames per second, we won't accept it. You must keep it very well organized, really good file names, really good variable names, overall organized. That is one of the most important things in this class. Like I said, AI is totally allowed. Just please cite it wherever you use it. Here I have a demonstration of what a link would look like. Cool. There is also additional freedom for you to add any extra features to your emulator that you like. We'll talk about this more later, but if you want to maybe get I don't know, weird shaders working, or if you want to do playback from a set of inputs from a file or something. There's lots of extra features that you can add, and honestly, a lot of the teams last time this course was offered, any teams that just got the basic ROM files working and that's it, finished the assignment but didn't do any extra features, they did not necessarily get very good grades. The people who got, the people who every single person in the team got an A, those were groups where there were really significant, really cool extra features that were added on. So maybe start brainstorming what cool extra features you would want to add. You're welcome to look at other video game emulators and try to replicate features that exist. Yeah, and cool. So then there's also a final project report due March 14th, the last Friday of class, and here are extra features. Cool. So that is the summary of the final project. Please read through it one more time. I kind of just skimmed over it. But yeah, okay, any other questions on this? Let me make a quick note that I need to fix the due dates. Any other questions? Cool. Yeah, okay, good. Okay, cool. So let's now look at what your starter code is. So hopefully you've kind of received, sorry, 1 second. So hopefully you have received your starter code. So what your starter code will come in is a little tar.gz file. So I have downloaded, here I just have the example team file. So you won't have the exact same files as this, but that is okay. I guess another big thing is please do not share your starter code with any other team. That is kind of the reason why you are able to that is why you're able to collaborate across groups. It's because everyone's emulator is slightly different. There are a bunch of different permutations. Every team has a slightly different emulator. And I kind of want to keep that obfuscated from you, the exact details from the differences between one emulator to the next. That way, you can collaborate on ideas, be I was implementing my opcode decoder this way, I was implementing it this way. But you can't actually use the code one-to-one. Instead, you have to think more in big picture. Thinking big picture is totally loud, but please do not share your documentation or your starter code with any other teams. I don't really want anyone to make a general purpose emulator. That kind of defeats the purpose of this course and would also make it so that I wouldn't be able to give this assignment to future quarters. I worked really hard to build out this emulator architecture. So I kind of like to keep teaching it like this as the years go on. So okay, cool. So this is the tar file. Okay. Let's pause for just a second. So if you ever receive a tar file, no, okay, hold on. So let's say someone's walking along on the street and then boom, stops you on the street and says, hey, quick, how do I extract a tar file? Okay, this happens to me all the time. I don't know if anyone else has this, but extracting tar files is just something that you should just know off the top of your head, no matter who you are. Okay, how do we extract a tar file? Okay, yeah. Yeah, tar-xzf. Okay, cool. Okay, turn to the person next to you. Say tar-xzf. Okay, cool. I guarantee you that will be on one of your quizzes and will be on the final. Okay, that's just something that you should just know. You should just know it. Unfortunately, like I don't know. Oftentimes I tell you like, oh, you can look things up in documentation or something. That's not something that you should ever look up in documentation. You should just know that. Yeah, question.
Yeah, what does that do?
So let me show you. So this when we do. Yeah, another question.
Is that just for .gz or?
Yeah, good. So we'll get there. So okay, so tar. So this is a GNU program which is meant for dealing with these tar files. And then X means extract, and then Z means unencrypt using gzip. So that's what this Z is. It's referring to this .gz part. And then F is the file name. So this is how we can extract out this this tar file. So I'm going to actually quickly, I'll make a new directory. I'll call it starter, okay? And then I'll cd into starter. And then I will extract this now. So I'll do type tar-xcf ... /example. So I'm now going to extract this out into my starter code, or into my starter directory. There we go. So now we can see I have this tar file, which had a bunch of files inside of it. Now I've just extracted them all out right here. So here we go. So this is what you all should have already. We can check out the license if we want, so we can see it is copyright of me. I created this emulator. Please do not distribute it to anyone outside of your team and or outside of this course. Okay, let's keep our voices down. Thank you. Cool. So inside this, you can see that you have a bunch of games. You have .slug files, and here GPU. So you can see we have .slug files for this. So the .slug files, these are the ROM files that you will need to run. But okay, but if we open this, it says, I don't know, it's not very interesting. Like we can try doing whatever, like // and then games and like Flappy Bird or something. But this obviously won't work because the format is wrong. So the goal of this class is, instead of doing this like // games Flappy Bird .slug, the idea is you will now write a program that will take in this .slug file and will run it as if we were just like, running this file and it was properly compiled for our computer. So, okay, but it's a little bit confusing to like know where to even start. I mean, here like VS Code is getting angry at me. It says the file is not displayed because it is, it's either binary, so it's like, I don't know, it's very confused. Well, one thing that we can do is we can click open anyway, and I have this this extension, this VS Code extension installed. You don't have to do it through VS Code. You can install a program to do this, but this extension is a hex editor. Okay, anyone heard of a hex editor? Anyone seen this? Okay, so we got a few people. So hex editors are going to be one of your best friends in this class. So a hex editor is really cool. So if you so maybe first let's think about a text editor. So a text editor opens up a file and then reads out all of the bits and everything inside that file as text. So for example, like VS Code is a text editor, because when I open up this text, you can see all of the text and it renders it nice to the screen. Great, cool. But what a hex editor will do is, instead of opening like each of the bytes in the file and interpreting it as a bunch of ASCII characters, instead what it will do is it will interpret it as its like actual hex values that are inside the file. And on the right side, we can actually see that this is what the data is as if it was interpreted as text. So this box.slug file, you can see that it actually starts out with a bit of text here. Similarly, like if I open up this license file in the hex editor, so there we go. So now I've opened this license file in this hex editor, and so we can see that here's all the text decoded, but here is now all of like the hex values. So when you open the file, like these are the actual bits and everything that make up this file. Yeah, question?
What is the license file for?
Oh, so the license file is just, this is very common in any sort of software project. You're generally also given a license, and the license just tells you in what capacity you are allowed to use the other files that are provided in the same tar file. So you may see licenses that say like no warranty provided, but like you may use but you may not create like a patent based off of it or something. There's all sorts of different license files that describe like in what manner you are allowed to use the other provided files here. So in this case, I've provided a license that is saying do not use any of the files, do not share any of these files. These files are for your eyes only. Yeah, but they're like open source licenses that are like, oh, like you can use this code wherever or something. Yeah, the question. This actually is legally binding because any creative work that any person creates by default falls under your own personal copyright. And you can, I mean, if I was really angry and like if one of you went and distributed all of this code to like Chegg or something, Chegg would probably be pretty upset that it like had this message on top because it meant that I could go and sue Chegg if Chegg were to release this. Or GitHub. If there's ever anything like this on GitHub, it gives me complete access to call up GitHub and be like, please take down this repo. Someone has posted my code. Here's clearly like a copyright message, and then GitHub will take this down. Or yeah, I could sue over this. Yeah, there we go. So yes, this is legally binding. Kind of the more important thing though is academic dishonesty, because before getting sued, you would first probably get kicked out of UC Santa Cruz. So that's probably the more immediate, like, bad thing. Yeah, no, very good question, though. Yeah, cool. So, okay, good. So here is box.slug. Okay, so as we said, so here is all of the text in it. But if we scroll down, well, then what happens is then we have like T question mark W3T and all this stuff. So like it started out as just text, but then it turns into kind of just gobbledygook. And so now the question is, well, how do we interpret this? So does anyone have any guess of what this bit of data all is? Like if you just assign a classification of what this part of the data is? Yeah. Yeah, so I would say, yeah, opcodes and instructions. So right here, this is probably just a list of instructions that the banana emulator is expecting to run. Okay, well, in order to figure this out, like we could try to reverse engineer everything, and actually, like, depending on what architecture you're trying to reverse engineer for, that may be what you need to do, is you need to look at like every single kind of like bit of code in this, being like, all right, like what's going on here? Like, oh, well, I will guess that it's this. Fortunately, we don't need to do that because I provided a nice bit of documentation here. This documentation explains exactly what happens inside of this, inside of each of the .slug files. So let me first, I'll open up a slightly simpler slug file. There we go. I'll open hello world1.slug. Okay, so cool. So this is the example team banana slug documentation. This will not be the exact same documentation that you receive, but it will be kind of good enough. Okay, and yeah, so what we could do is we could scroll down, we could see, so we have CPU instructions. So if I click on this, then okay, so it looks like this is how CPU instructions are created. So it looks like the first, however many bits that is, I guess like 6 bits right here is the opcode. And then the next however many bits is describing the registers. Okay, has anyone seen this before in like CSE111? Okay, cool. Has anyone not seen this kind of diagram before? Okay, good. So most of us have seen it. If you haven't seen it before, not to worry, just maybe check in with your group mates, see if you can all kind of figure out what this is by the end of the week. But yeah, so this is describing the structure of an instruction. Notice that it's different from RISC-V. I'm sure most of you have looked at like the RISC-V instruction set. This is much simpler than RISC-V. All we have is just an R-type and an I-type instruction. That's it. We don't have to worry about any of the other fancy types. Okay, and then here is an explanation of all of the different instructions. So here we have add immediate with the opcode specified, jump instruction opcode specified, and it also describes the function of each of these instructions. And so what you will probably do is every time maybe you get to a specific instruction, like I don't know, maybe if we're like reading this right here, okay? So this is a single instruction, it's 4 bytes. Maybe we could go and pull up the instruction documentation and figure out exactly what is happening here. So maybe let's try to do that. Although oh, here we go. Okay, cool. So good. Okay. Maybe take a second, and I would like you all to figure out. This is going to be too small. Hopefully not. Okay. I would like you all to figure out what the opcode is of this specific instruction. Okay, the instruction that I've currently highlighted. Okay. So we can see the opcode. How many bits does the opcode take off the top? So you can see it's bits, it's kind of hard to see, but it's bits 26 to 31. So that would be 6 bits because it's inclusive. So if we go and look at this instruction right here, it says it is 111 and then 00000. So we can take just the top 6 bits of that, which I think is going to be, we can think of it as like 7 times 8, I think, so 56. Is that what other people got? 56? Yeah, okay, cool. So let's double check, maybe, hopefully I did this right. Hopefully this is even an instruction. Let's scroll down, do we see 56? Oh, 56. Oh, okay, so what's the instruction? Store byte. Great, cool, awesome. So we've done that. Now we could keep going through. We could figure out what this is. Actually, sure, yeah, let's figure out what this is. So the top 6 bits off this is, okay, so that's 9 times 8, no, times 4, 9 times 4, 36, right? Is that what people are thinking? So maybe yeah, 36, okay, so what instruction is that? Or immediate. Great, so this is an or immediate instruction. Cool, okay, so this, I'm feeling good, right? There's not too many instructions here total. How many instructions are there? I don't know. There's to say? Yeah, so there's only 10 instructions here. So that the chance that we just so happen to like stumble on valid instructions would be pretty low if these were random. So obviously these are in fact instructions. This is a stored byte instruction. This is a or immediate instruction. So yeah, you're going to be spending a lot of time looking at the hex editor and trying to figure out what instructions are coming next and what things aren't working. Oh, you know what? Maybe I should have first showed you how to use a hex editor. Hopefully no one's too lost on this. But okay, wait, really quick. So this is a hex editor. So the idea with the hex editor is that it shows you all of the bytes in the file, but it also shows you the address of each of these bytes. And this top row right here specifies the address offset it's just the address with the bottom 16 like least significant, or the bottom 4 least significant address bits. So we can think like, so here this is address 0, then this is address 1 and 2 and 3 and 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is address 15. And then in order to get to address 16, we would just pop around to the bottom, and now we have this base address of 10, and the offset is 0. So this would be address 16, and then this would be address 17, because it would be this 10 plus 1, because in in hex, 10 is 16. Cool, okay. Try to experiment with this, get a hex editor installed this week and try to open up some of the slug files, see if you can find out some of the instructions. Cool, okay. But cool, so now we know that we have a bunch of instructions here, and if we want, we can try running each of the instructions and seeing what registers things get written to and whatnot. Probably though, the first thing that I would want to do is just figure out where this is supposed to start. Because we have a bunch of instructions, but it's kind of hard to tell, like, I mean, where's the entry point into this? Like, I mean, maybe we should just start at the beginning, but like, how do we even know that this is the beginning? Like, maybe this is something else. Like, yeah, it'd be nice to know exactly what is going on. And what we can do is we can look at the documentation. We can figure out exactly like what is the starting address of everything. Okay, so if I were handed this document, maybe the first thing I would do is I would search up, I would try to like look up on this document, I'd look up like entry point. Okay, anyone tried this yet? Has anyone found what address this starts at? Okay, yeah, because we don't want to just like start the program right in the middle or start it. So, okay, so let's look up like entry. Okay, oh, you know what? That didn't exist. Okay, what about reset? Okay, oh, cool. Okay, so reset. So it looks like reset is similar to like the entry point, often used interchangeably. So okay, so here it explains, okay, so what we need to do is clear all RAM with zeros and then copy data section to RAM, so whatever all this. But then it says, okay, call setup. So we can now search for setup and see what setup is. So okay, so it's talking about setup and oh, okay, all right. So what does this say? Where is setup located? Yeah, cool. So setup has, setup is specified to have its like value, like the location of setup, the address to setup is stored here. Just the address, not actual setup, but the address to setup is here. So okay, we can check this now. So 81E0, great. Let's try to find the address to setup. So if we go to 81E0, okay. Well, if I scroll all the way down, oh, well, actually, it looks like we can't get to 81E0. Why can we not get to 81E0? Okay. What was that? Well, if we look, what's the length of this file? Well, it's less than 8,000. So in the documentation, it said, oh, like here's the address. So it's at 81E0, okay. But I just tried going to 81E0, but it only goes up to 8,000. So unfortunately, okay, so we can't just pull up this address inside of this slug file, okay. Okay. Unfortunate, so we need to keep digging a little deeper. But let's check out this address space section. This is probably important. Okay, so the address space, has anyone heard of an address space before? Okay, cool. Maybe you're familiar with it, just not from this terminology. I'm gonna actually switch to my iPad now. Okay. Cool, this is fun. I've never had like a dual, it's cool. Okay, anyways, so the idea with an address space is that if you have some large array, maybe let's think about an array that has like, I don't know, this many elements, right? We could think of like each index into this array as an address, right? So this might be address 0, address 1, 2, 3, 4, and 5, right? This is an array, yeah. Well, the banana slug address space is describing every single byte that our emulator potentially like has access to. So in our emulator, we are allowed to have, I'll just tell you right now, we are allowed to have a 16-bit address, and that's something that you can find in the documentation. So you're allowed a 16-bit address. So how many elements will our address space array have if we can have a 16-bit address? Does anyone know? Top of your head? What would it be? Yeah. So if our address width is 16 bits, oh yeah. What was that? Yeah, it would be 2 to the 16. Yeah, so that would be the size of our address space. So instead of just like these 5 elements here, we would have like 2 to the 16 possible elements, which will be about 65,000, I think. 65? Yeah. So I'll say, also known as, I think, 64 kibibytes, I believe. Cool. So this is like quite large. It's a big address space. And what we can see, if we go back to the documentation, so here it explains, so okay, the RAM address space, it says that it starts at the address of 0. So it looks like right here, this is actually the RAM, and it goes up until 7,000. So cool. So, sorry, let me do, yeah, no, that's fine. Okay, so it looks like this is the RAM. So all of this is actually a huge, like, size OX7,000 size section, like that's a bunch of elements. And then after that, then we have another section right here, which starts at address 7,000, and goes up to OX7 to whatever. So it looks like this whole section right here is about the I/O, okay? Right, because it starts at 7,000 and just keeps going up, and I guess it doesn't really have an end. Yeah, okay, cool. And then after that, then we have the slug address space. So the slug address space starts at 8,000 and then has 8,000 size. So this whole section right here, this is our slug address space. Okay, so maybe we can guess that even though we wanted to access this 81E0 address, maybe instead, what address do you imagine that we should instead be looking at inside of our hello world 1.slug file? What is the actual address into this file? What is the offset into this file to get us that 81E0? Yes? Yeah, exactly. It would just be 1E0. Yeah. Unfortunately, this file just crashed. So, okay, there we go. Yeah, cool. So, yeah, so in order to get this 81E0, because of this big offset, we will actually only be needing to grab just 1E0. Okay, so right here, cool. So this right here, these 4 bytes, these represent the starting address of our program. It is the address to startup. So the address is 8280. So we can probably use the same logic where we can get rid of this kind of preceding 8 here. So it's probably just like 280. So let's now scroll down, okay? And so now we can go to address 280, and it looks like this right here is the very first instruction. Cool, and that is something that you will need to implement. You will need to, this right here is a hard-coded value, this 81E0. So you go into that hard-coded value, so 81E0 right here, and you will read out this value, which is could be anything. It could change. It could be any value. But in this specific case, it looks like it's 8280. So we save that value to an integer or something, and then we go and start running, we start our execution at that address, which, will then run this instruction. Cool, okay. Would anyone like me to say that again? Is it making sense? Is it okay? Okay. Yeah.
So, the first part, is that just, the words on the right side?
Mm-hmm.
Because it starts, the second those words stop. So it's the, part in front of it at the top, is that just for those, your statement or whatever?
Exactly. Yeah, yeah. So it happens that and this is very common. Binary files will very commonly have either some blurb at the front or maybe some metadata or something. It'll have just like pockets of kind of unrelated just stuff in the file. That's very common where you'll just have a bunch of padding. And it is your job to look through the documentation and find the like hard-coded address that will initiate everything else in the file. Yeah, exactly. Cool, okay. So hopefully this is making sense. There's one final thing that I wanted to show you. I'm trying to remember what it was, though. Okay. Good. Okay, yeah, so this is the address space. This is maybe one of the most challenging parts to kind of understand. At least it was one of the hardest things to understand for the last course offering. What I would recommend doing as just your first step of this project, the first thing that you should do is create a like banana memory space or address space class. And the address space class should have a large array that should have all 64 kilobytes in it. You should just have this large array, and you should be able to read and write every single byte inside of this array. And then the CPU, when you eventually create the CPU class, it should access data out of this large a memory array. That is probably the first step, is just getting the memory address space working. Yeah, it should just be a big array, and you read and write from that. So that should maybe be your goal for this week, is trying to get the memory accesses working. See if you can also try to read multiple bytes at a time. See if you can implement like a read 1 byte, read 16, read 32. See if you can work on that, because that will also be helpful. Okay, yeah, another question.
What would be like an example of a function like after you read, like what would it print out? If you read like a specific set of bytes?
Sure, so this address space is just a contiguous set of bytes, and so a read 16 would read a 16-byte integer, sorry, a 16-bit integer. It would just read, a 2-byte integer, and it would properly handle like the correct endianness. And so it would return an integer. Yeah. Cool. Okay, so that is hopefully a good enough kind of introduction to the Banana Slug project. We will continue talking about it this week. However, we are going to enter our quiz now. So the quiz, I think, has already been initiated. So I think you can start on it right now. Please, you may work on it with one partner. It is a GitHub-related quiz. We'll talk a little bit about the questions in class, so try not to submit like immediately. We go and come up with a good answer, wait for a second, and then we'll chat about the answers collectively. But yeah, please go and pull up Canvas, log in, and get the quiz all set up. Choose your partner. Please keep your partner and you like together. Don't try to collaborate with people who are not your partner. If you're trying to work with someone who's like more than 1 seat apart, then go and scoot closer to each other. Okay, good. You have until the end of class to finish this. So I'm going to start walking around. Charles will also start walking around, just in case anyone has any questions. Please no ChatGPT, no Googling things. We will talk about it together, but make sure to read the rules. Okay. So, Git versus GitHub. Maybe just shout it out. So Git, of course, is it's a version control thing. What's the difference between Git and GitHub? Maybe just shout it out really quick.
Git is version control. GitHub is a web-based platform.
GitHub, what does it do with Git repositories? Yeah, okay, so it hosts them. Okay, I like that. Sure. And then GitHub Actions, right, or continuous integration. So if you run if you push, right, then GitHub Actions will be run probably automatically for you. If a test fails, what happens? Yeah, okay, sure, you get an email. If the test succeeds, what happens? Okay, nothing. When you all set up GitHub Actions for homework 1, did you need to pay anything? Okay, no. And I don't remember if I mentioned this, but so GitHub Actions also is not the only way of running continuous integration. You can also run it through other platforms. I think I have a couple listed on the canvas, right? Okay. Okay, and so if you now have a Git repository and you want to make a change to it, and maybe this change will take over a month to implement fully, would you want to just do it directly on main, or what would you want to do? You would want to create a new branch, right? And what do I call this branch in the quiz? It's called a feature branch. Okay, cool. So in a feature branch, how do you switch to a feature branch? Yeah, okay. And then how do you create a feature branch? Yeah, with the -b, right? Okay, sure, cool. All right. I think I've covered most everything. Any other? Yeah. Question?
What are the YAML files?
Oh, sure. So what are the YAML files? YAML file. Any explanations of what the YAML file is? Yeah.
It's what GitHub Actions use to determine what to run.
Exactly. Yeah. So a YAML file is what GitHub Action uses to determine what to run. A YAML file is just a file type that stores data. So it's like a JSON file or an HTML file or a CSV file. It's just a file storage format that just so happens to be used by GitHub Actions. Yeah, the question?
So, for the one that's if CI fails on the feature branch, it'll pass on does that mean I make a change to the feature branch, but I don't make a change to main, and it's asking because the CI passed on main?
Sorry. So the question is, let me pull it up really quick. So, where is it? Sorry. Oh, yeah, okay. So the question was on this wording. If CI fails on a feature branch, it will most likely pass on main without changes. Actually, no, I do see the confusion. Maybe a better wording for this would be if a CI fails on a feature branch, and then I merge that feature branch into main without any additional changes, will main now pass that CI? And it will probably not pass, right? Because if it failed on the feature branch, probably means there's a bug, probably means you need to fix something, and so when you merge it into main, you will also see that it will fail. So therefore, you need to add an additional change and fix it. Yeah, maybe I should fix that wording for next time. Okay, yeah?
Is there a default CL that builds when you make a new GitHub repository?
Is there a default CI that was created? Like when you created GitHub repository, is there an automatic GitHub Actions that's run for you? Yeah, generally no, right? It's usually, like if you download a specific template, then maybe. Yeah, but usually you have to be the one to create the GitHub, the continuous integration setup. Yeah. Anything else? So the idea with CI is anytime you make a change, then there is a server that will automatically run a job for you.